Statistic, yep. Statistic, yep. Statistic, yep. Statistic.
Hello, this is my stats final. Unfortunately, this is the view we're going to have to work with. I will move my phone around during certain points of the presentation, so don't worry. But we have Kiowa School's height. So my level of measurement is ratio. It's ratio because heights can have a meaningful 0 point and because you can be twice as tall as someone else. My type of data is quantitative because we are working with numbers and units of measurement. My claim is that 8th to 9th grade is when you start to grow, is when your growth spurts really start kicking in, and my data will show that. So this is elementary. My mean is 46, my standard deviation is 4.8. My upper class limit is 60.4, my lower class limit is 31.6, and my class width is 7.2. The reason why these are zeros is because there's a certain range of height. Obviously, we're working with elementary, little short kids, so it makes sense as to why they would range in just certain places. So here is my histogram. I would say it's symmetric, just kind of based off of how it would flow. But this is the histogram. This is my normal distribution. Our mean is 46, upper class limit 60.4, and lower class limit 31.6. And this isn't the accurate normal distribution. This is just a template for one. And here's my pie chart for all of the heights. 9 kids are 41 and 48 inches tall, which is 15.3% out of all the kids. And our tallest height, which is 54 inches, is 1.7%. So on to middle school, our mean is 62.9, standard deviation 3.5, lower class limit 52.4, upper class limit 73.6, class width 7.1. Here is the histogram. I also say this one is symmetric. Can you see it?
Did you see it?
Here is the normal distribution. 62.9 as the mean, 73.4 upper class limit, 52.4 lower class limit. And here is the pie chart for middle school. 8 kids are 62 and 63 inches, which they are both 19% of the kids. And our tallest height is 74 inches, which is 2.4%. And our shortest height is 54 inches, which is also 2.4%. High school mean 67.4, standard deviation 3.3, lower class limit 57.3, upper class limit 77.7, class width 5.1. So this is the histogram for high school and adults. I said it's symmetric, but also a little skewed right because of the outliers over here. Okay, it's not outliers plural, it's just one person, and it's not really an outlier, it's just someone who is just a little bit over the average, 74.5 inches tall, and they are a 12th grader. Here is the normal distribution. 67.4 is our mean, 77.3 upper class limit, lower class limit 57.5. 11 people are 69 inches, which is 15.9% of the high school and adults, with our shortest height being 58 inches, which is 1.4%, and our tallest height being 74.5 inches, which is also 1.4%. So the reason I make the claim that I do is because when we look at the middle school heights, we only have 4 people outside of the 5-foot height, and everyone else is 5 foot or above that, with only one person being way above that, and that person is a 8th grader, and this person is a 7th grader. But again, that's one heck of an outlier. So when we look at high school, we can see that there's only one person that is outside of the 5-foot range, and after that, everyone is just skyrocketed past that, with 5'9" being our averagest height. So, as you can see here, high school is when you really start to grow. And so with that, I have my questions. I can only answer one question because I need help with 2 of them. So I will be there for that tomorrow. But I do have one of them answered. And that is, what's the probability that someone in high school will be at least your height? And that probability is 13%. Because for me, I am 5'8", which is 68 inches. There were only 9 students in high school that are the same height as me. And a total number of high school students, 69. That we collected, and 9 divided by 69 is 0.13, so 13% chance that someone in high school will be the same height as me.